This video is an introduction to similarity. If we look up here in our fill in the blanks, figures are congruent if they are the same size and same shape. The angle measures and the side lengths are exactly the same, but they do not have to be oriented the same way. That means they don't have to be turned or positioned in the same way. Determine if each set of figures is congruent or not. Label them and justify your reasoning. Are these two congruent? No, they're not. They're not the same shape or size. Number 2. Yes. Same shape and size. Number 3. Yes. Same shape and size. And number 4. No, not the same size. So when we take that and we look at similar figures, in order for figures to be similar, they must be the same shape. The corresponding angle measurements must be equal or congruent. And the corresponding side lengths must be proportional. So the figure below are similar. Determine the corresponding angles and the corresponding side lengths. So if we had these two figures and you turned this figure, that right triangle, and set it on top of that right triangle, which angle is the same as angle A? So if you took that and turned around and set it there, so it would be angle A and angle D. For B, angle B, it would be angle E. And for angle C, it would be angle F. So if we turn that around, let me just draw it here for you guys. That's angle E, that's F, and that's D. So side length AB is the same as side length DE. Side length BC is the same as side length EF. And side length CA is the same as side length FD. They're all congruent angles and congruent sides. And if we look at scale factor is the ratio of corresponding sides in a figure. So if we look at these, we've got the new over the original gets us the scale factor, okay, when you have corresponding figures. For figures to be similar, they must have the same ratio or scale factor. These shapes are labeled by corresponding angles, so they will start in the same point and go in the same direction around the shape. Prove that the figures below are similar by finding the scale factor. So this one's the new, this one's the original, and this one is the new. So if we take 20, and it's the same size here as there, so we put 20 over 5, and we get 4. If we take this 10 and this 2.5, we also get 4. So the scale factor for those two figures is 4. Come over here to 7. This is the original. And this is the new. We can set it up 2.5 over 5, 2.5 over 5 is equal to 1/2. And we also can set it up 3 over 6. And you also get 1/2. So the scale factor for those two figures is 1/2. Based on questions 6 and 7, what do you notice about the scale factor of an enlargement? So if the scale factor is greater than 1, it enlarges the figure. If the scale factor is less than 1, it reduces the figure. And if you have a scale factor that equals 1, it stays the same. All right, let's look at the last problem down here, number 9. Parallelogram QRST is similar to parallelogram WXYZ. Determine whether each statement is false, true or false. So I'm going to attempt to draw this one here. That's going to be X, W, Z, and Y. So angle QRS is congruent to angle ZWX. They are two totally opposite angles, so the answer there is false. Angle R, and this is the first figure, this is the second figure. So we've got angle RS over the first figure to XY over the second figure. And then you've got ST over YZ, and those are the same, so that is true. Angle STQ is congruent to YZW. These two are the same, so that's true. So you've got ST over the first one, over YZ over the second one. Then you have WZ over the second one, over QT over the first one. They are not congruent or matching, so the answer there is false.